Okay, hello. My name is Melek Topchu, and my problem for Moron is 27.5. And it goes as follows. So let the function of f, where x squared is the outcome, if x is less or equal to x naught, and ax plus b is what we have if x is larger than x naught. So in order to solve this problem, we want to find the coefficients of a and b at which the function is continuous and has a derivative at the point x naught. In order for that to happen, f and f prime, or the derivative of f, have to be continuous. And have a derivative. Oh, let's just put it like this. In order to find the solution, at x naught. So let's just assume that our function is in fact differentiable. So let's assume. In this case, we again go back to our thing, and we know that our function is x squared when x is less or equal to x naught, and ax plus b when it is greater than x naught. Right? So then we go forward on the continuity of our function. So continuity of our function. And we see that using the piecewise function, we can say that the limit as x tends to x naught from the left hand side is equal to limit as it tends to the same corresponding thing from the right hand side. And this, of course, is equal to the function of f of x at x naught. In order for the function to be able to have continuity or to be continuous, it has to be continuous through the point x naught as well. So therefore we can we can just put x naught in substitute x naught in our formulas here and equate them. So this would look something like x naught squared would equal to 2 a x naught plus b. And this is our first formula. So this is a, make no mistake, this is our first formula. Now let's find the continuity of our formula, the derivative of our formula, which is f prime of x would equal to the derivative of x squared is 2x for x is less or equal to x naught, and just the derivative of ax plus b, which is x this and a. For x is greater than x naught. Right, so again, for it to be continuous at every point, it needs to be continuous at the point x naught as well. So we just substitute and we get, and using the piecewise function as we have here, from the left-hand side and right-hand side, we get the function that goes, we get the equation that goes a equals to 2, x naught being substituted for x is 2x naught. Right, so from here we can gather our first variable, a, and then we can just substitute this value of 2x naught into our first equation. So then we will gather and have x naught squared will equal to, instead of a we put this value, we get 2x naught like this, multiplied to x naught plus b, which in itself will of course be x naught squared will equal to 2x naught squared plus b. And when we subtract these values, we get b will equal to minus x naught squared. And these are our two values, proving that it can be continuous and have a derivative at the point x naught and q, e, d. Ladies and gentlemen. Oh.